Hey there, this will be a short video where we're going to go through one more example of using partial derivatives to work with an equation that defines a surface. But if you look at this, this is not written as z is equal to a function of x and y. Instead, this is an equation that implicitly defines the surface that we have here. So if we have a surface that's defined implicitly, let's see what happens if we try to find the derivative of z with respect to x, this partial derivative of z with respect to x, and the partial derivative of z with respect to y. All right. So when you have a function that's defined implicitly, then just as when you're dealing with a function of two variables back when, what we want to do is we want to take the derivative with respect to x of both sides. So but this time it's the partial derivative with respect to x. And so when we're doing this, we see the one thing that we'll be using here that will make our life a bit easier is that when x and y are independent variables, then taking the partial derivative with respect to x of y is just going to be 0. On the other hand, if we have the derivative with respect to x of z, maybe some function of z, like z cubed, then in this instance, the partial derivative with respect to x of z cubed is going to be 3z squared, but then you need to take the derivative with respect to x of z. So that tacks on a del z del x term. So let's now go through and do this calculation. What do we have here? The derivative with respect to x of x cubed. So the partial with respect to x is 3x squared. The partial with respect to x of y cubed is just 0 because y is a constant. And then the derivative with respect to x of z cubed is going to be 3z squared times del z del x. Now we have to take the derivative of a product. So when we're taking the derivative with respect to x, 6 and y are constants, so let's bring that out, 6y. And now we have x times z, so we'll have to use the product rule. So we take del x of x times z plus del x of z times x, all equals 0. Expanding, what do we get? We get 3x squared plus 3z squared del z del x plus 6y times z plus 6y times x times del z del x. All right, this was the chain rule. And now we want to solve for del z del x. So we'll keep these terms on the left-hand side, bring the others to the right-hand side. So what do we get? We get 3z squared plus 6xy times del z del x is equal to negative 3x squared plus 6yz. And then we get del z del x is equal to negative 3x squared plus 6yz, all in parentheses, divided by 3z squared plus 6xy. So if we do that again in terms of y, then we'll get these two equations for del z del x and del z del y. All right, let's stop there. See you shortly.